What I cannot create, I do not understand. Richard Feynman. Ever wondered how frameworks like React actually work under the hood? What if you could build your own front-end framework with templating, virtual DOM, and state management in just a few minutes? Let's tear down the magic and rebuild it from scratch. Most tutorials teach you how to use frameworks, but today we are engineering one. Here is what we will cover. First, we will start with templating, converting JavaScript templates literal into a real DOM elements. Then we will import a virtual DOM, yes, like React, Vue, Angular, to update our views. After that comes the game changer, state management. We'll build your own reactive system that automatically updates the UI when data changes. Finally, we will bring it all together to create a real-world component with change deduction. No black boxes, just pure JavaScript mystery. Whether you are a curious React developer or you want to level up your core JavaScript skills, by the end of the tutorial, you will never look at the framework the same way. Stick around until the end, where I will show you how to extend your framework with advanced features. Let's jump in. Not to mention that will give you higher opportunities in the job market. You can just go to any company and show this project on your CV. That would be a very add value. By the way, I have done a lot of tutorials before, like TypeScript, Python, prompt engineering, and a lot of short, valuable courses. If you are interested, you can visit my channel. And by the way, by the time you're watching this, I will have posted a new challenge. Just to drop me any course idea and I will do it. Thank you very much. I will answer all the comments in this video if that possible statistically. Now getting started. Requirements. You have to know HTML, JavaScript, and Git. If you don't have basic understanding of JavaScript, please don't waste your time watching this course. If we're talking about your system, you have to have Visual Studio Code, Git, and Node.js, and got to know any framework. It's not required, by the way, but it's just good to know. Okay, let's go to the setup. I know most of you have already Git, Node.js installed, and Visual Studio Code installed. I think you miss Visual Studio. Just install Visual Studio like any program and select these two options: Node.js development, desktop development with C++. By the way, I would like to thank and give a shout out for Marvin Farshid for creating this beautiful documentation about how to create your own front-end framework. I have inspired this course by his website, so he deserves a shout out and special thanks. Now let's clone the repository. I will leave the link of the repository in the description. Follow up with me. You wouldn't clone it like any other repository. Just clone it. Open the project in your Visual Studio Code. Folders. .cache contains cached files used by Parcel to speed up development process. It's automatically generated and usually deleted during build or serve comment. Book. This is probably where the documentation for the project resides. The docs and docs build script in the package.json use ViewPress, which is the documentation generator that processes content here. Build. This folder is where the bundled output of your project will be placed. After running the build script, it will contain optimized production-ready files. Test. Another output folder created when serving the project in the development mode using Parcel serve. Docs. This folder is generated when you run build docs script, which uses ViewPress to compile and move your documentation to a new location. Framework, likely where core framework logic resides. Package.json, it might contain the custom front-end framework code. Node modules contains all dependencies and packages installed via yarn or npm. Source likely holds the source files of the project, although its content aren't listed in the provided structure. This is probably where you will write your framework code. files. .babel rs configuration file for Babel, which is used to transpile modern JavaScript ES6 features into backward compatible JavaScript. In this project, Babel is configured with env preset for modern JavaScript. .getIgnore specifies which file and directories get should ignore. Index.html, the HTML entry point for your project, likely tied to Parcel server. Index.js, an empty file currently, but it's the main entry point for the application. Package.json define the metadata for the project, including dependencies, development tools, and the scripts for building, serving, and documenting. readme.md, documentation for the project itself, usually explaining how to set up, run it, and contribute. Yarn.log, log file generated by Yarn to ensure that the project installed the exact same version dependencies across different environments. Key components. Parcel. Parcel is a zero configuration web application bundler that handles the build process. In this project, it's used for both serving and building the framework. ViewPress. ViewPress is used to manage the project documentation. Snabbdom. Snabbdom is a virtual DOM library used for fast rendering and manipulation of DOM element. It is a core component for building lightweight, fast front-end frameworks. The project might rely on this library for rendering the framework's UI. Babel. Babel is included to ensure the code bases uses modern JavaScript features while being transpiled to a form compatible with older browser. It helps in writing cutting-edge JavaScript without worrying about compatibility issue. Scripts in package.json. Build cleans the build directory and bundles the application using Parcel. Start delete any existing .cache and disk directories and serve the application locally using Parcel. This is your development server. Docs runs a local development server for the project's documentation using ViewPress. Build docs builds the static version of the documentation, moves it to the docs folder, and make it ready for deployment. Template literals as template engine. Before we jump into code, let's break down template literals. A template literal allows us to embed expressions inside string literals, which means we can include dynamic values in a string without resorting to complex string connections. Here you can see how simple it is to include variables directly inside the string. But today we are taking this concept even farther by turning template literals into a template engine. In traditional front-end framework like React or Angular, you typically use JSX or other templating languages to render dynamic HTML content. But did you know how you can use tag template literals to achieve similar results without additional libraries? Let's walk through how to set up basic front-end framework using the approach. The first step is to create folder for our framework. Inside the folder, let's create file named element.js. This file will define our first HTML element. Here we define a simple def function that takes tag template literals as input. This allows us to dynamically process any content inside the template. This syntax, strings, args, breaks down the template literals into two parts, static string and dynamic values. Now let's run the code in Node.js to see how it works. Simply type the following command in your terminal. When you run this, you will get something like that. The result is an array of static strings, hello, space, and an array of dynamic values, Marvin, Farshid. The tag template breaks down the literals into pieces that we can manipulate. The strings array contains all static text around the dynamic expressions. In our case, hello, a space, and an exclamation mark. The args array captured interpolate values such as first name and last name. Now that we have broken down the structure, let's build a more complex example by using these arrays to render dynamic HTML. Before that, what is reduce? Reduce method combines all elements in an array into a single value. Here, how it works in our function. Starting point, the initial value of ACC, short for accumulator, is an empty string combining element. For each current string in this strings array, it adds the current string the corresponding values from args, if it exists. This continues until all parts are combined into one string. Using the function with tag template, we use our function in a special way with tag template. Here is what's happening. Div is our function. The back tickets create a template literals. Inside the template, first name and last name are placeholders for our variables. Finally, we log the results. When this line run dev process, the template literals combine all text and variables into one string. Hello Marvin Farshid. Abstracting for other HTML elements. As developers, we are lazy people and we don't like code duplication. Let's abstract a bit the element creation so that we can use other HTML elements easily. We will see how to create dynamic HTML-like elements using JavaScript functions. Don't worry if it sounds complicated, I'm going to make it super simple. The create element function. First, we have function called create element. Here it is what's happening. Create element tag name. This function that takes a tag name like div p return another function. It returns a new function that can handle template literals. Strings and arg, these represent the fixed text and variables part of the template literals. Just like in the previous example, reduce combines all parts together into one string. When you call create element, you are creating a function that will process template literals and combine text and variables into one complete string. It also includes a type which holds the name of the tag, div, p, or whatever it is. Step 2. Creating specific elements. Next, create two specific functions, div and p. Div, the function will handle for div elements. P, the function will handle templates for p paragraph elements. Okay, what is happening here? P, we are using p function as tag for template literals. Template literals, the back tickets, create template literals, which is with first name and last name as placeholder. Combining parts, the p function combine all the text and variables into one string. Destructuring, we are pulling out the template part of the object that the p function returns. In this line, we are using something called destructuring assignment. Let's break it down. What is destructuring? Destructuring is a feature in JavaScript that allows you to unpack value from object or an array into a separate variables. What does template mean? Here, templates, it's a way to saying take the template property from the object returned by p and put it into a variable named template. It is as simple as that. It is time to create the framework index.js. It will act at the core of our framework. It will simply take the previously created element and add it to the DOM. You start by creating a core function that will handle adding elements to the DOM. This function is located in framework index.js. Here is the code. The first line, select the DOM element where you want to render the content. The second line, it is just create a new HTML based on the component type. In the third line, create a text node from the components template. Fourth line, append the text node to a new HTML element. Finally, append a new element to the selected DOM element. Create and export the div and p elements. Now you will need to define the div and p elements using tag template literals. This is done on framework elements.js. Initialize the application. With everything set up, you can now initialize your application by rendering the component in the DOM. This is done in index.js. How it works: create elements with tag template. The create element function allows you to create elements like div or p with dynamic content using tag template literals. This function takes tag name like div and the template literals parts, static strings, and dynamic values, returns an object containing the elements type and template. Render elements to the DOM. The init function handled actual rendering. It takes a CSS selector like app and components like the object returned by div. It then creates corresponding HTML element files it with the template content and appends it to the selected element in the DOM. Dynamic content. The example uses variables first name and last name to dynamically insert content into div. When you call init, it outputs hello Marvin Marshett inside div. Starting the application to see everything in action. Make sure you have div with ID app in your index.html. Then simply yarn start. Open your browser on localhost 1234. You should see hello Marvin Marshett displayed in the page. Adding more element. You can extend this framework by creating more HTML element using the create element function. For example, if you want to add span element, you could do this and use it similarly in your application. This approach provides a simple, flexible way to create render HTML element dynamically in your JavaScript application. Let's walk through how to create reusable components in your framework by following step provided. This will allow you to use component-based approach similar to how modern framework like React operate. Create the user component. You'll start by creating a new file, user.js, inside source folder. This component will be function that generate the HTML structure using the div tag template literal. Here's how you do it. Create source folder and user.js. Inside your project directory, create a new folder called source if it's not exist already. Inside source folder, create a new file named user.js. Define the user component. Inside in user.js, write following code. Explanation. User is a function that takes an object with the first name and last name as properties. It returns div element with text hello first name last name using tag template literal. Step 2. Modify index.js. Use the user component. Next, you will update your index.js file to use a new user component instead of directly using a div or p element. Edit index.js. Open your index.js file and replace its content with following. Explanation. The user component is imported from user.js. You then pass first name and last name as arguments to user, which generates the appropriate HTML structure. Finally, the init function is called within the app selector and result of the user function, which inserts the component of the DOM. Step 3. Run the application by the command yarn start and view it in the browser. What is virtual DOM? First, let's talk about the DOM or document object model. The DOM is like a family tree that represents all elements on your web page, like heading, images, paragraphs, and links. Each element is a node in this tree and they are all connected together. When you update something on your web page, like changing text or adding new image, the browser needs to update the DOM. But here's the thing, interacting with the real DOM can be slow, especially when your page has a lot of elements. Imagine having to update a huge tree by hand. It's not very efficient. This is where virtual DOM comes in. The virtual DOM is lightweight copy of the real DOM. It's like having many versions of your family tree that uses to quickly figure out what is changed. Here how it works. When you make a change, the virtual DOM update first, then it compares the updated version of virtual DOM with real previous version to see what's the difference. Once identifies the changes, it's update only those specific parts of the real DOM. This process is super efficient and keeps your app running smoothly. For example, if you change the text from like to subscribe, the virtual DOM update first, check for differences, and then makes that small change in your real DOM. The rest of the page stays the same, and the updated version happens almost instantly. Thanks for virtual DOM, apps can handle updates much more better, leading to faster load times, better performance, and a smoother experience for users. Existing VDOM implementation. VDOM is more a concept or a technique. It exists a portions and multiple options implementation of such a thing. Vue.js uses a fork of Snabbdom For the sake of simplicity, we will use Snabbdom as well. In this project, let's go. Let's walk through how to integrate Snabbdom, a virtual DOM library, into your framework. This will make your DOM manipulations more efficient. As Snabbdom, we will handle updates in the most optimized way, only modifying what is necessary. Why add a virtual DOM like Snabbdom? In your framework, you've been manually creating and updating DOM nodes. This approach works, but as your application grows, it's become inefficient to manage all possible changes in the DOM by hand. The virtual DOM, VDOM, solved this problem by creating an abstraction over the actual DOM. Instead of making changes directly to the DOM, which can be slow, you make changes to the virtual DOM. The library then compares the virtual DOM to the actual DOM and updates only the parts that need to be changed. Snabbdom is lightweight virtual DOM library that makes the process easier and more efficient. Step 1. Install Snabbdom. First, you will need to install Snabbdom using either npm or yarn. Me personally, I do prefer yarn, so yarn install Snabbdom. Step 2. Update your create element function. Next, you will refactor your create element function in framework element.js to use Snabbdom H function. This function allows you to create virtual nodes instead of directly creating real DOM nodes. Here is the updated version. Explanation: H function, Snabbdom H function, short for hyperscript, creates a virtual node. This node represents potential DOM element that Snabbdom can later use to update the actual DOM. Type elements. This helps identify the kind of node you are dealing with, which will be useful for future operations like handling events. Step 3. Simplify the end function. Now that Snabbdom handles DOM updates for you, you can simplify the init function in framework index.js. Explanation: Snabbdom.init. This initializes Snabbdom, creating a patch function. That empty array is where you could add Snabbdom models, like for attributes, events, whatever, but you don't need any for this basic setup. Patch app component.template. This compares the current DOM represented by app with the virtual DOM represented by component.templates. Snabbdom then updates the real DOM to match the virtual DOM efficiency. Step 2. Running the application. With these updates, your application will be now benefit from the performance optimization provided by Snabbdom. The virtual DOM will ensure that only the necessary changes are made to the actual DOM, keeping your application responsive and efficient. To test out, run the application by yarn start. View the output, open your browser and go to the localhost 1234. You should see the same output as before, but now it's being managed by Snabbdom virtual DOM. Adding event handling with the Snabbdom. Now we have integrated Snabbdom for efficient DOM manipulation. It's time to add user interaction capabilities by handling events like clicks. We'll break down the process step by step to keep everything clear and manageable. Refactoring the create element function. First, we will refactor the create element function to make it more readable and maintainable by splitting out the logic that handles transformation of template strings. We will create a helper function, create reducer, to handle the transformation logic. Update create element with refactoring. Explanation: initialize state include template key for the HTML content, an on key for event handler. Create reducer. This function now handles both the string connections for the template and the event handling logic. Create element. The H function from Snabbdom is used to create virtual nodes, and the on object is passed to handle events. As you see in this code, initial state for template and event, the on added to manage event handlers. This function to reduce template literal into a string and manage events. if the current argument is an event added to the onObject, otherwise concatenate with the string with a function to create an element using Snabbdom H function, exporting div and p elements. Creating an event handler. Next, we will create our first event handler for the onClick event. This will allow us to specify what happens when user clicks on the element. Creating the onClick event handler. Framework event.js. Explanation. OnClick. This function returns an object representing an event. The click property stores the function that will be executed when the event occurs. Using the event handler in a component. Let's use this event handler in a simple component that displays a usernames and triggered an alert when clicked. Using onClick component. Explanation. OnClick. The onClick handler is attached to the div element. When clicked, it triggers an alert showing the first name. Configuring Snabbdom to handle events. By default, Snabbdom does not include event handling capabilities. We need to include the event listeners model to updating Snabbdom initialization. Go to framework index.js. Explanation. Event listeners model. This model allows Snabbdom to handle DOM events like click by including it in snab.init. We enable Snabbdom to manage events in our components. Testing the implementation. Now, when you run your application and click on the text displayed on the screen, you should see an alert box showing the user first name. What is the state of an app? The state of an application is like snapshot of all the important data and conditions at specific moment in time. It represents what your app looks like and how it behaves at the moment. Understanding state with a concrete example. To-do MVC. Let's break down the concept of state using simple to-do MVC app, which is common example for learning about state management. Initial state. When you first open to-do MVC app, it initials a state. The list of to-dos is empty. The text input field where you type a new to-do list is empty as well. State change in your user interaction. As your state typing something in the input field, the state of app changes. The to-do list remains empty. The input field now contains the text you have typed. State after adding a to-do. When you press enter, the app state changes again and a new to-do item appears in the list, so the to-do list now has one item. The input field is cleared, returning to an empty state, representing with code. Let's look at how concept of state can be represented in a code. Const T1 state. First name Marvin, last name Farshid. State 2 transform. State 1 last name Thoms. Now T2 state is first name Marvin, last name Thomas. Explanation. T-state, it's represent initial state of the application where username is Marvin Farshid. Transformation function. This hypothetical function takes current state, T1 state, and updates it when some new transformation. In this case, changing last name to Thomas. T2 state, the new state after transformation where the username is now Marvin Thomas. How frameworks manage states. Every front-end framework has its own way to managing and transforming the state. The core idea is to track the state updated when something changes, like user input, and then re-render the user interface based on new state. This process ensures that what is the user sees on the screen always reflects the current state of this application. Here, how you can achieve the same functionality using useState hook in a functional component in React. Okay, this course, it's not about React, but I will explain it very fast in order to explain this idea. Use state hook. Use state Marvin initialize the state with first name set to Marvin. It returns an array where the first element is the current state value first name and the second element function set first name to update the state itself. Modifying the state. Set first name Thomas is called when the change name function update first name to Thomas. Re-rendering. The component renders the current state first name in a paragraph a button is provided to trigger the change name function, which updates the states when clicked. Now, building our own state management system. What is our approach? We are going to create a basic state management system inspired by a approach we have discussed. The core idea is to maintain a state object and provide a function that can modify this state. Let's break it down. Initial state. We start with initial state, a simple object that holds the default values for our application's data. State modification function. These are functions that take the current state and some parameters as input and return a new state based on the modification we want to make. Step 1. Define the initial state. First, we need to define the initial state of our component. This initial state acts as default starting point of our application. In this example, the initial state contains first name and last name. Step 2. Create moderating function. Next, we create a function that will allow us to modify the state. These functions take the current state and parameters, then return a new state with the updated values. Explanation. State. This is the current state of the component. First name. This is the new value we want to set for first name. Return value. We return a new state object using the separate operator state to copy existing state and overwrite the first name with the new value. For example, if you want to change first name from Marvin to Thomas, you would call this. The output should be first name Thomas, last name Farshid. Here, new state now hold the updated value with first name changed to Thomas while keeping last name unchanged. Step 3. Organize mutating function. We can group this mutation function into an object called method. This way, we have centralized place to manage all state mutations. Explanation. Method object. This object contains all the function that can modify the state. In this case, we have just one method, change name. Now, whenever you want to update the state, you can use one of the methods from this object. Summary. Initialize state, the starting point of your application data. State mutation for function. Function that takes the current state and some parameters to return new updated state. Method object, a collection of states, mutation functions, making it easier to manage state changes through your application. This simple approach to state management gives you the flexibility to manage and update your app state in a controlled and predictable manner, creating real-world components in our framework application. Understanding components in different frameworks. In popular front-end framework, components are typically created in standardized way. Angular components are defined using class declarated with component. React components are created by using the React.component class, the old way, or using functional components, the new way. Vue.js components are created using new Vue. Now, we are going to create our own way to define components in a custom framework. Our goal is to build something similar to the way these frameworks handle components, but tailored to our specific needs. Step 1. Define the create component function. We want to define a function called create component that will help us to generate components. The final result will look something like this. This function will combine a template method and an initial state to create component. Step 2. Implement the create component function. Let's dive into the implementation. Import necessary models. Start by importing Snabbdom for our virtual DOM management. Patch initialization. We initialize Snabbdom with support for event listener. Create the create component function. This function will take in an object with template method, and here's what this might look like in framework index.js. Explanation. Template, the structure component, HTML-like structure with data binding. Method, a set of functions that can mutate the state. Initial state, the default state of the component. Props, the properties passed to the components when it's used. The function create components, it's a querying function, meaning it returns another function that actually represents the component. This is common pattern in functional programming to create reusable and configurable functions. Step 3. Create the user user components. Now that we have our create component function, let's define a real-world component called user. This component will display the user first name and last name, trigger an alert with the first name when clicked in source user.js, implement the user component. Explanation: initial state define the starting values for first name and last name. Method contains function changed name that can update first name in this state. Template describes how the component should be rendered. Here is the div with onClick event that shows an alert with the first name. Step 4. Running the application. Once you have created the user component, you can start your application as usual. This screen should display the username as before, and when you click on it, an alert with the first name should pop up. This setup allows you to create component system where the structure, template, behavior, method, and data initial state are neatly packaged together. You now have framework that can manage components just like well-known frameworks such as React, Angular, or Vue.js. Change deduction. Explained simply, when building web application, you often have a user interface (UI) that shows certain information. When this information changed, the UI to update to reflect those changes. This process is called change deduction. How change deduction works in different frameworks. Vue.js uses system called observable to track changes. When you create property in Vue like a name and a form, Vue keeps on eye that property. If you change the property, Vue automatically the changes and updates the UI without needing to do anything extra. Example: Angular handles change deduction differently. It assumes that any changes to the application state happens through even clicks, typing, or other users' functions. Angular uses a tool called zone.js to listen to these events. Whenever an event happens, Angular checks if anything in this application has changed and updates the UI immediately. Example: React. In React, you need to manually tell the framework when something has changed. You do this method called setState. When you call this method, React creates a new version of the UI with the updated data and compares it to the old version. Only differences are then updated on the screen. Now let's break it down into simple steps for you. Now we want to make our application dynamic. Right now it doesn't do much, but we are going to add functionality that allows the app to change when something happens, like when users clicks a button. Adding functionality to our component. We'll start by adding method or functions to our component. This method will update the app state. Basically, they will change the data in our application is working with. Updating the framework. First, let's go to framework index.js file. Here we are going to update our create component function to accept method. This method will be used to change the state. Here's how you update it. This change allows us to use method in our component, using method in our components. Now let's put this into action. In our source user.js component, import necessary functions. Define methods. We create change name method that update the first name in the state. Set initial state. We start with name in our state. Create the template. This is where we define what our components look like. We add a click event that trigger our change name method. Create the component. Finally, we boot everything together. Create our component. Handling state changes. Whenever we call method like changeName, it updates the state with a new value. This is done automatically in our framework, so you don't have to manually pass the state around. Here's the key part. Let's break down and explain it. This code, step by step. State initialization. This variable state will hold the component's current state, like first name, last name, whatever. Initially, it's an empty object, but it gets set to the initial state. When you create the component creation function, parameter, template, a function that define what the components look like, its HTML structure, method, function that update the state, change name, For example, initial state, the starting values for component state. Inside the create state component function, the state is set to the initialized state. This is where the component data begins. Previous, this will store the last rendered version of the component virtual DOM. It's for compression during updates. Patching. Mapping method for state updates. Mapping method, this function creates a set for method from the method object that update the state and render the components for each method like change name. It creates a wrapper function that will wrapper update the state and then re-renders the components. Reduce function, object.keys methods reduce, iterates over the keys of the method object for each method. It creates a new function in mapped method. When a method like change name is called, update the state method. The state is updated based on the method. Create next virtual DOM, const next node template props state method. This template it's re-evaluated with the updated state. Patches the DOM, patch previous.template next node template. Snabbdom compares the old vDOM previous and new vDOM next node and updates the real DOM with only necessary changes. Store the current vDOM previous equals next node. The current vDOM is saved for future comparisons. Rendering the component. Initial rendering. When the component is first rendered, this function is called with props. It creates the initial vDOM by calling template with the current props states and map method. The vDOM previous is returned, ready to be patched if the state changes. Okay, now it's the final step, making the application reactive. In this last part, we are going to complete our app by ensuring that when our component state changes, the view what the user sees automatically updates. This is done through something called vDOM comparison and DOM patching. How it works. Virtual DOM. As we said before, the virtual DOM is a lightweight copy of the actual DOM. It allows us to make changes without directly manipulating the real DOM, which can be slow and inefficient. When a change happens like updating username, the vDOM compares the old version before the change with the new version after the change. It then updates only the parts of the real DOM that need to be changed. DOM patching. DOM patching is the process of updating the real DOM based on differences found in the vDOM comparison. This means our app only updates what's necessary, making it fast and efficient. Implementing vDOM and patching. Let's look at how we put this into action. Import Snabbdom. Snabbdom, as we said before, is a library that helps vDOM operation. We import it and initialize it with the necessary models like event listeners. Initialize the component, the end function setup for app selecting the DOM elements where our component will be rendered. Create the components. Now we get hurt this part of the code. Handle the state management and re-rendering the components when change happens. How it comes all together. State management. This state object holds the current state of component. Method or function that updated state. Rendering. When method is called, like changing username, the states update. The template function creates a new version of the vDOM based on the updated state. Snabbdom patch function then compares the new vDOM with the old one and updates only the necessary parts. End result. Whenever a user interacts with the component, such as clicking a button, the app reacts immediately. The state changes and only the necessary part of the page updates, making your app feel smooth and responsive. And that's it. You have now completed your own state management system with vDOM handling and efficient DOM patching. Your app is now reactive and ready to handle dynamic content like Pro. Additional feature to consider. Now that you have built a basic front-end framework, there are several advanced features you can explore to make it more robust and scalable. Here is a list of potential improvement Children re-rendering. What is it? Well, allowing component to render other component or element inside them. This is essential for building nested or complex UI structure. Why it's important? It enables more modular and reusable design, where components can be composed of smaller dependencies unit. How to implement it? Well, you would modify your create component function to accept and render child components. Might be involve passing children as prop and ensuring they are rendered within parent template. Managing lifestyle. What is it? Managing the different phases a component goes through: initialization, motion, updating, and animating. Why it's important? Lifestyle management is critical for tasks like fetching data, cleaning up resources, and optimizing re-rendering. How to implement? Introduce lifestyle hooks like on-mount, on-update, on-unmount that let developers tap into these phases to execute custom logic. Improving performance. What is it? Optimizing the framework to handle a large-scale application efficiency. Why it's important? As applications grow, performance can degrade, leading to slower load time and poor user experience. How to implement? Memorizing cache results of expensive operation, batch updates, group multiple state updates into a single render cycle to minimize DOM operations. Virtual scrolling, only render elements currently in view, useful for long sites. Managing style encapsulation. What is it? Ensure that component style do not leak or get affected by external styles. Why it is important? This avoids CSS conflicts and make components truly modular and reusable. How to implement? Shadow DOM. Utilize the Shadow DOM API to encapsulate styles within components. CSS in JavaScript, another approach where your style tightly coupled with components using JavaScript. Dependencies injection systems. What is it? A design pattern where your dependencies like services or other components are injected into a component rather than hard-coded. Why it's important? This promotes flexible and makes your components more testable, maintainable. How to implement? Create system where your dependencies can be passed into a component during their creation, possibly via context or service locator pattern. Now you have created your own front-end framework and you know what to do next. Please tell me in the comments if you have any questions. Thank you so much for watching